Dear students, in previous videos, we have seen what do you mean by ensemble learning and the first type of ensemble learning, that is bagging. In today's video, we will concentrate on second type of ensemble learning, that is boosting, and we will also see what are the similarities and differences in between bagging and boosting. So let's start with boosting. Now, what was happening in bagging? We were dividing our data set into batches. That may be a vertical division. Vertical division means what? When you are having data set which is containing rows and columns, then randomly any column you will put in one batch, the remaining columns will put in another batch, and these columns which are inputted to model. Models will work independently on these columns. They will work parallelly in bagging, and finally we will combine prediction to get the final prediction. But in boosting, what is happening? Whatever are your models, the first model will predict some data, and the output of first model will act as an input to the next model. So this model is known as a weak classifier because that model is not giving me 100% accuracy. That model will bear some loss. So that loss will be taken as a training parameter for next level model. So finally, this process will be repeated and we will get a strong classifier by combining multiple weak classifiers. So what is the second point telling us? So the new model means the model at the next level is having aim to correct the errors which are made by the previous one. So just concentrate on highlighted words so that you will understand the actual definition of boosting. Means, though you are having multiple models in boosting, the next model will not start its working unless and until it get the output from the previous one. So the model 2 is waiting for the output from model 1. Means the processing should go as in sequential direction. M1 will complete its work. Then only we can proceed to M2. So boosting is working parallel sequentially, while bagging is working parallelly. Are you understanding? In bagging, multiple modules are working parallelly, independent of each other. But in boosting, modules are dependent on each other. The errors we obtained in the previous module is acting as an input to the next module. So in boosting, the operation is sequential. Now, this process should be continued up to what point unless and until we get the strong classifier. But when you will assume that you have obtained a strong classifier, when you have got the prediction with highest accuracy, means all your data set is accurately predicted, then that will become the stop point in boosting. Or the second stop point is the maximum number of modules have been worked. Means predefined maximum number of modules are being executed. Then my CPU is not capable of processing the next module. That is only processing power of my CPU. Then that will become the second stop point. So in any of these cases, you will stop and whatever prediction you have obtained at that point, that you will consider as a final prediction in boosting. Okay. So as you can see in diagram, no? You are having your original data set that you will divide into batches like subset 1 to M. Okay. Now each subset will be given as an input to individual algorithm. So that algorithm I'm calling as a weak learner because it is giving me some true predictions, some false prediction. Whatever is the accuracy of that model, that will be considered as a true prediction. And whatever is the loss, that is the difference between the target and predicted, that will be considered as a false prediction. So this false prediction should act as an input to the next module. Unless and until I reach this false prediction, I will not start working of my next module. Okay. So just see the numbering. Input the batch 1, perform the training, then get the prediction, then only you can proceed next. Then again, this process should be repeated unless and until you will get accuracy which is at the acceptable level. The loss at the acceptable level means final prediction you have reached. Okay, so this is what the process of your boosting. Now, how will be our boosting algorithm? First, we will initialize weights. Now, what is the role of weight in boosting algorithm? We know that in boosting algorithm, we are getting a strong learner by combining multiple weak learners. Now here, strong learner is achieved a less weight and weak learner is assigned a more weight. Okay, are you understanding? Strong learner has been assigned a less weight while the weak learner has been assigned a more weight. Okay, so initially I don't know who is strong learner, who is weak learner. So initially I will assign some weights to each learner. Okay, so each of your algorithm, each of your model, each of your module will be assigned some weight, and that weight may be equal weight. Okay, initially. Then I will execute the first algorithm. That is the first model will be compiled and fitted and trained. Then I will get its prediction. So I will calculate the error at that point. And based on that error, I can say whether it is a weak learner or whether it is a strong learner. If it is a strong learner, doesn't matter. But if it is a weak learner, then I should update the weights. So how much weight I should give to the weak learner? More weight. Okay. So higher weights will help me to correctly classify misclassified data. Okay. Now this process should be repeated. The steps in 2, 3, 4 should be repeated several times unless and until I get final prediction with acceptable accuracy. And that prediction I will forecast as output of my boosted ensemble learner. Okay. Now what is the purpose of boosting? One model is considered as a weak model because it is not giving me satisfied accuracy. It is not giving me accurate prediction. That's why I'm aggregating multiple weak learners to get a strong learner, to get a strong model. That is what the main purpose of boosting algorithm. Now here you can see in the diagram that original data you are inputting to the classifier. Then some of the data is predicted accurately. So this is indicating the accuracy of your classifier. But this much data is predicted falsely. Means it is wrongly predicted. These many data points are misclassified. So this is considered as a loss of your model. So that loss will only act as an input to the next classifier. Okay, so here you can see that it is called as a weighted data. So these weights are assigned based on the loss of previous classifier. Okay, then this process will be repeated and unless and until you get the final prediction, that is a boosted ensembled classifier you have to achieve. Okay. Now, what are the advantages? Of course, we are going for ensemble learning to improve our accuracy, to avoid overfitting. Means we want proper accuracy in both phases, that is the training phase as well as testing phase. Now, one more advantage that is observed in boosting is it is capable of handling imbalanced data. Now, what do you mean by imbalanced data? Whatever are labels, whatever are classes in your data set, to all these classes, nearly same number of tuples are not allocated. There is a lot of variation in those tuples. Then such data is known as imbalanced data. And it is having a better interpretability. Means it is capable of generating model with high accuracy. Okay. Now, what is the disadvantage? Now, as you have seen that it is not working parallel. Boosting is sequential. Unless and until first model complete its prediction, you can't move to the next model. Then in that case, the next model has to wait. So a lot of time is wasted in this waiting. So in real-time application where you want a quick response, then it is not useful in such cases. And as more and more computations are involved, it is computationally expensive. It is causing a cost to your CPU processing power. As well as there is a risk of outliers, means data which is beyond my range. boosting algorithm does not work properly on such data. Okay, its accuracy is affected by such outliers. So this is what the disadvantage of your boosting algorithm. Now, what are the types of the boosting algorithms? There are four types. One is gradient boosting. Just give a look in the highlighted words because the remaining all parameters will be same. That is what your boosting algorithm. Okay. Now here, what I'm doing is I'm not dividing my data set in batches. The whole data set I'm giving as an input to first learner. Okay. So based on its accuracy and loss, I will decide whether it is a strong learner or weak learner. And based on that, I will assign weight to it. And my final prediction is what? Sum of all these predictions. Okay. Now here I'm concentrating on the residual. Residual means what? Error. Whatever error has been arrived in first learner, based on that whether it is a weak or strong, I will consider. And then only I will proceed to the next level. Okay. Now, in extreme gradient boosting, it is same as your gradient boosting. Only the difference is we are getting a regularized model. What we are getting? A regularized model. Now, what do you mean by regularized model? Regularized model is also known as a generalized model, the model that is capable of working on any kind of data, whether it is a known data or unknown data. Means the model that is not giving me the problem of overfitting. In overfitting, what is happening? The model works well in training phase, but it does not work well in testing phase. So that problem I'm not getting in regularized model. So that is what the main advantage of your extreme gradient boosting. Now the next one is what? ADA boosting, in which I will consider a alpha parameter, which is telling me the error of the weak learner. Okay, so the alpha parameter is whole and sole based on the error of weak learner. It is indirectly proportional to the error of the weak learner. So alpha parameter is deciding your learning rate. Why it is indirectly proportional? If error is more, then learning will be less. That's why it is indirectly proportional. Then cataboost. As the name is suggesting, it is capable of working on the categorical data. There are two kinds of data in our data set, categorical data and numerical data. Unless and until you convert categorical data to numerical data in some classifiers, we can't proceed. So such conversion is known as a encoding. So the types of the encoding are categorical encoding, ordinal encoding, etc. Okay. Now, what is the another property of your cataboost is, suppose you are applying it for the random forest, then every model will give you a decision tree. Then these decision trees are symmetric. Now, what do you mean by symmetric? It will have same left subtree and right subtree. So that is what called as a symmetry. Means the left subtree and right subtree are mirror image of each other. So these are the properties of your cataboost. So these are the four algorithms that you are using. This comparison is not that much important. Means just to remember the properties of each type of boosting. The comparison is out of your syllabus. Just for extra knowledge, I have given it. Okay. Now, what are the applications of boosting? Boosting will be used in the case where you need a regularized model. Okay. So it may be in the image and object identification. It may be your natural language processing. It may be the fraud detection. And as we have seen, ensemble learning is best suited for medical field, where you want to diagnose a disease with highest accuracy. Okay. Then in recommendation system and even in the time series analysis. Now, when we are coming for the comparison of bagging and boosting, then what are the similarities in between the bagging and boosting? We know that both bagging and boosting are the types of the ensemble learning, where there will be n number of the algorithms. And we are not depending on the prediction of only one algorithm. We have to aggregate the predictions of all the algorithms. Then for that purpose, we can go for either voting or averaging. And both are aiming to reduce bias and variance. So these are the similarities. Now differences. While going for differences, you can see that in these two slides, I'm listing nearly 9 differences. Okay, but how to remember these differences easily? That I will let you know. The first one, very important point. Bagging is working in parallel while boosting is working sequential. That's why in bagging, each model is independent of another model. But in boosting, the model performance is affected by the performance of the previous model. Okay. So the models are dependent on each other. Independent, dependent. Okay, this is the first point. The second point, bagging will decrease the variance while the boosting will decrease the bias. So because of variance, you are avoiding the problem of overfitting. Because of bias, you are avoiding the problem of underfitting. Okay, so these are the 3 points. Then the next one, the example is a random forest. The example may be any type of the boosting, that is a gradient boosting, extreme gradient boosting, ADA boosting, or keta boosting. Then the next thing is how it is working, that you can tell. Okay, means here all the models will be working in parallel to each other, and finally I will get the prediction by voting or averaging. And here you can say that multiple weak learners will be combined together to get a strong learner. Okay, so these are some points. So it is not the case that you should by heart all the 9 points. Just remember 4 to 5 important points. The first one, bagging will work parallel, boosting will work sequential. Models are independent, models are dependent on each other. Decreasing variance, decreasing bias. Will avoid the problem of overfitting, will avoid the problem of underfitting. Okay, then what will be the working of bagging and what will be the working of boosting? Then example random forest, example any of your boosting category, ADA booster, keta booster, that you can tell. So how many points you have learned? The first one is how it is working, then whether it is dependent or not, then what it is decreasing, which problem it is avoiding, what will be the kind of working, and what is the example. So remember these 6 points when comparison of bagging and boosting is asked to you in exam. Okay, so it is an important question in unit 3. So in this video, we have seen what do you mean by boosting, what is boosting algorithm, types of boosting, and the comparison of bagging and boosting. Thank you.